In order to add or subtract a radical or multiple radicals, you need to know how to simplify a radical. If you don't know how to simplify a radical, I'm going to be going over it a little bit as we solve each of these problems, but you need to go back and look at the simplifying radicals video on the class website under Unit 1. All right, so let's talk about how we add and subtract radicals. So here are the things to remember. In order to add or subtract a radical, the roots must be the same. Okay, so here's what I mean by that. Got 3 square root 3, all right? In order to add that to something else, it has to have the same radical, like 7 root 3, or 5 root 3, or 2 root 3, or negative 2 root 3, or negative 5 root 3, okay? Has to have the same radical. See how we have root 3, root 3, root 3, root 3. They all have to have the same radical, okay? Well, let's look at another example. So let's say I have 4 root 2, all right? Something I could add to that would be another 4 root 2, or 3 root 2, or 9 root 2. Okay, what I couldn't add is like 3 root 7, all right? That won't work because they have different radicals, okay? So let's see what that would look like. Let's clear page. All right, so if I have 3 root 3 plus 5 root 3, when we add them, the radical will not change. So the root 3 part will stay the same. So in my answer, I'll have something root 3. All right, and all I need to do is add my 2 coefficients together. I get 8, so my answer is 8 root 3. Okay, let's do another one. What if I had 4 root 7 plus 9 root 7? That would give me 13 root 7. So I'm adding the coefficients, but the radicals stay the same. Okay, let's do one more. So negative 5 root 11 plus 7 root 11. 7 and 11. All right. So the root 11 stays the same. And then negative 5 plus 7 is 2. So 2 root 11. Okay. So now let's talk about what you do when you have radicals that are not the same. All right. You're going to see problems like this when you get ready to practice in a second. So express in simplest radical form. So I got negative 7 root 2 plus 6 root 8. Right now, they're not the same. But sometimes you can simplify one of the radicals or both of the radicals to make them have the same root. All right, so negative 7 root 2. We know how to simplify radicals. Root 2 cannot be simplified. There's no perfect square that can divide into 2. All right, when I say no perfect square, I'm talking about our list over here. This is what you need to watch in the video on simplifying radicals. All right, these numbers, I'm just going down the list, trying to divide. All right, will any of these numbers divide into 2? No. So that's going to stay the same. Now look at 6 root 8. Inside of root 8, can any of these numbers here, can any of these numbers divide into 8? 4, yes. All right, 9 is too big, 16 is too big, so we can just stop there. 4 is the only number. All right, so what we're going to do is break 8 out into, bring down the 6 first, but 8 becomes 4, root 4 times root 2. Because root 4 times root 2 will give us root 8. All right. So square root of 4, we know what that is. So that's going to become 2, just taking the square root of 4. And then this root 2 stays the same. So now I can multiply 6 and 2 together. I get 12 root 2. Okay. So I've simplified 6 root 8, changed it to 12 root 2. Now, let's bring down negative 7 root 2. And guess what? I can add them now because they have the same root. Okay. So negative 7 root 2 plus 12 root 2 just becomes 5 root 2. Okay. That's your answer. All right. Let's do another one. All right. So again, let me circle all my perfect squares. I'm not going to use 1 because 1 does not help us get to a different number. Anything divided by 1 is itself. So we start with 4. Okay. So 7 root 7. Can I simplify that? No, there's no number. None of these numbers on this list will divide into 7. All right. So that's out. That stays the same. Now look at the next one. Negative 5 root 175. You're probably like, oh my goodness, what in the world, 175? But look at that number 75. What do we know about 75? 25 divides into 75 evenly. So 25 might divide into 175 evenly. So let's try it. 175 divided by 25 is 7. So it works. All right. There's no other numbers. You can try 36. You can try 49, 64, 81. 100, none of these numbers will divide into 175. All right, so this becomes negative 5 times root 25, and it was 25 times 7. Uh-oh, that's ugly. Let me rewrite that. Times root 7. Okay. So just to recap, we broke 75 out into 25 times 7. So let's simplify. Square root of 25. That becomes 5. You don't need the root anymore. But 7 will stay inside of the radical. Okay. So now multiply these two together. I get negative 25 root 7. Okay. Now bring down the other radical. So I got 7 root 7 minus 25 root 7. So 7 minus 25 is negative 18. And then the root 7 stays the same. Bam. Okay. All right, let's do one more. 3 root 2 minus 5 root 72. So look at 3 root 2 first. Can root 2 be simplified? No. There's no number from our list that can divide into 2 evenly. Okay. So move on to the next one. Negative 5 root 72. Inside of root 72 is a couple of perfect squares, actually. So let's start with 4. 4 does divide into 72. 72 divided by 4 is 18. But we want the biggest one, so let's keep going. 9 does divide into 72 as well. 9 times 8. But let's see if there's anything bigger. 16 into 72 is a decimal. That's out. 25 doesn't work. Let's try 36. 72 divided by 36 is 2. So it does work. 49 doesn't work. 64 doesn't work. 81 is too big. So we're going to use 36. All right. You want the biggest one. Don't stop too early. All right. That's the most common mistake. All right. So I'm going to break that out into 36 and 2. Okay. So 72. We're just breaking that up into 36 and root 2. All right. So the square root of 36 is 6. Comes out of the radical. Root 2 stays inside. Let's go ahead and multiply these two together. We get negative 30 root 2. And then bring down 3 root 2. So I got 3 root 2 minus 30 root 2. That becomes negative 27 root 2. Okay. All right. So that is it.